Gravity, the force that keeps us grounded, the invisible hand that holds planets in orbit, shapes galaxies, and bends light itself. But what if gravity isn't what we think it is? What if, instead of being a fundamental force of nature, gravity is just an illusion, something that emerges from a deeper, hidden reality? This idea may sound strange, but some of the greatest minds in physics have questioned the true nature of gravity. So, is gravity real, or is it just a trick of the universe? For most of human history, people had no idea why objects fell to the ground or why planets moved across the sky. The motions of the stars and planets were a mystery, something explained through mythology and religion rather than science. Then came Isaac Newton. In the 17th century, Newton proposed that gravity was a force, a universal force that acts between all objects with mass. He realized that the same force that pulled an apple to the ground also kept the moon in orbit around the Earth. He gave us a simple but powerful equation to describe it, an equation that could predict the movements of planets and moons with stunning accuracy. Newton's theory of gravity worked, and it still works. We use it to send rockets into space and calculate the orbits of satellites. But there was something strange about Newton's gravity. His equation said that gravity acted instantly, that the sun's pull on Earth was immediate, with no delay. But how could the sun pull on Earth from 150 million kilometers away without anything physically connecting them? This was a mystery, and it wasn't until Einstein arrived that we finally began to understand the deeper nature of gravity. In the early 20th century, Albert Einstein proposed a completely different way of thinking about gravity. Instead of being a force that acts at a distance, Einstein suggested that gravity is actually the bending of space and time itself. Imagine space as a flexible fabric. When you place a massive object, like a planet or a star, on this fabric, it creates a curve. Smaller objects, like the Earth orbiting the Sun, follow these curves, just like a marble rolling around a funnel. This was Einstein's theory of general relativity, and it changed everything. It explained why planets move the way they do. It predicted the bending of light around massive objects. It even revealed that time itself slows down in strong gravitational fields. But even Einstein's theory had a problem. When we look at the smallest scales, at atoms and particles, gravity seems to disappear in the world of quantum mechanics. Space and time themselves start to behave strangely. And general relativity, as powerful as it is, no longer works. This is where things get weird. Some physicists believe that gravity isn't a fundamental force at all. Instead, it may be an emergent phenomenon, something that arises from deeper, more fundamental laws. One of the most intriguing ideas comes from string theory and quantum mechanics. It suggests that gravity might not be a real force, but a side effect of something else, something hidden in the quantum world. Imagine a hologram from the right angle. It looks like a 3D object, but in reality, it's just a 2D surface storing information in a clever way. Some scientists believe our universe works the same way. Gravity and even space itself might be an illusion, just the result of information being processed at a deeper level of reality. This is known as the holographic principle. Another radical idea comes from physicist Eric Verlinde. He proposed that gravity isn't a fundamental force, but a result of something called entropy, the natural tendency of systems to become more disordered over time. Imagine you have a room full of air molecules. They don't all gather in one corner of the room. Instead, they spread out, filling the space as evenly as possible. This happens because of entropy. The universe naturally moves toward more disorder. Verlinde suggests that gravity is like this. Instead of being a force pulling things together, gravity might emerge from the way information and energy are arranged in space. Just like heat emerges from the random movement of molecules, gravity might emerge from the way information is organized. If this is true, then gravity isn't a fundamental force. It's just the universe naturally organizing itself. But there's an even deeper problem with gravity. When we try to merge general relativity with quantum mechanics, everything breaks down. In quantum physics, particles can exist in multiple states at once. They can pop in and out of existence. They follow strange, probabilistic rules. But general relativity treats space and time as smooth and continuous. When we try to combine the two, we get contradictions and infinities, answers that don't make sense. This suggests that something is missing. Maybe gravity isn't a force at all. Maybe space and time themselves aren't fundamental. Some theories suggest that space and time are made of tiny bits of quantum information. Just like water appears smooth but is actually made of tiny molecules, space might appear smooth but is actually made of tiny, discrete units. If this is true, then gravity is just an illusion, something that emerges when we zoom out, like the way temperature emerges from moving atoms. So, is gravity real, or is it an illusion? Right now, we don't know. Newton thought gravity was a force that acted instantly across space. Einstein showed that gravity was the bending of space and time. Now, some physicists believe that gravity is just an emergent property, something that appears at large scales but doesn't really exist at the deepest levels of reality. The truth is, we don't yet have a complete theory of gravity. We know general relativity works on large scales. We know quantum mechanics works on small scales. But we don't know how to fit them together. Gravity remains one of the biggest mysteries in physics. Perhaps one day, we'll discover the true nature of gravity. And when we do, we may finally understand the deepest secrets of the universe itself.